Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. All right, welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and Fred's starting a worrying trend where we start talking, but he doesn't tell me what we're talking about, so...
Well, it's not
cue
that
embarrassment.
bad. Well, it's like when we get a comment in, or a question in the mail, it's first cup of coffee and you're reading some interesting question or something like that. And I got one yesterday that I thought would be perfect to talk about.
Cool.
Because I figured you probably have thought this through pretty well at one point or another, but it's actually...
we'll see.
Well, we'll see, yeah. No, it was a question that was, in part, it was... the question was, I'm paraphrasing, it was, I got this stack of data, a pile of data, and what's the first thing I should do with it? And because they heard the comment that I've made, I don't know how many times, is plot the data. Well, is that the first thing you would do? And so I thought, well, there's a little bit more to this. In my own experience, vast majority of the time is the plotting is the easy part. There's a whole bunch of other things we can do once you first get a stack of data or a pile of data or come upon some interesting data or whatever. So what do you think? What's the very first thing you should do?
Well, what's the decision?
No, I didn't even think of that one. Yeah. What are you going to do with it, right? What are you trying to accomplish, or what's the problem or question you're trying to solve, or is that what you mean?
Yeah, I mean, I'll give you an example. I was recently given a stack of data to look at, and this data, for all intents and purposes, satisfied the perceived need, i.e. it contained information about warranty failure. And that's fantastic, and the information for these warranty failure events was pretty good. And they said, well, can you go and analyze and tell us about warranty reliability? And I said, well, problem is you haven't given me any information about the devices or systems that haven't failed. So you've given, let's just say, it was a lot of data. So let's just say there's 1,000 data points. I go, well, if you sold 1,000 systems, then your warranty reliability is quite poor. In fact, best guess is zero.
Yeah.
They said, well, we need to give you that information. Well, of course you need to give me that information, because how do I know what fraction of systems failed if this is the only data you've given me? And more beyond that, you and I know that if you can, even just a simple Weibull plot can tell you so much about what's going on. Is it wearing in? Is it wearing out? Is there more than one failure mode or more than one failure mechanism? And to be able to create a Weibull plot, you need to have what we call censored data included, which is information about how old all the surviving products and systems are.
Yeah.
And so that's a good example of people rushing to get data without truly understanding what it is we're trying to decide upon or inform.
Well, they had all this failure data. If they wanted to just analyze that part of it, it's only part of the story. And so in part you're saying is that they wanted to understand what proportion of units were failing, and the data wasn't sufficient to answer that question. But it's also, I think a part of it is, do you have the appropriate data or enough data or the right columns of data sets, those kinds of things. One thing even before that is, well, I've been handed data before and none of the columns were labeled. I'm like, all right, what is this? Just analyze it. I don't even know what it is,
Right. And you can make some educated guesses, like you can see where the technician comments usually are.
Yeah, or the dates might have a rhythm to them of some sort. But if you got a set of data, I also go back even further. Is, well, where and how is this collected? If I wasn't the one actually doing it, well, what's the source of this stuff? And it goes back to your point: is this data complete, or is it? Was it collected well? I've actually been handed a physical stack of worksheets. There was repair records, and they the repair folks would put in the serial number, what unit it was, and they would list or scan in what components they replaced, those kinds of things. And then they had a table below it that was the root cause. It was attempting to go at, well, what actually caused the problem? And after paging through about a dozen or so of these, it was the first one underneath the last field that they were required to fill in was the one always ticked. And so sometimes they replaced the capacitor. Sometimes they replaced another component. They replaced out of the 10 I looked at, there were like 8 different things that were actually done. But every one of them had faulty CPU as the tick mark of what was the root cause. And none of them replaced the CPU. So, wait a second. What is it? If I was going to make a simple chart of, what was the root causes, I think this is not accurate. Let me see how you fill this in. And it led to an experiment where we randomized the boxes that were to be indicating what the various types of root causes were. And sure enough, it was the location dominated, the one closest to the last required field. And I'm like, well, this isn't helping.
No. Well, it's a really good point you raise. Going back to the example I talked about earlier where I was given a ton of data, apparently allegedly warranty failure data. And I looked at the data and I knew what the warranty period was. And about half the data points, half these failure events occurred at usages beyond the warranty period. You go, all right, so this is not exclusively warranty failure. You ask the person to go to, yep, it's supposed to be exclusively warranty failure. And that sort of discrepancy is what good data analysts and reliability engineers should be looking for. Because as soon as you see that, as soon as you see something which doesn't align with the brief of the data set, your spidey senses should start tingling and say, okay, there is a disconnect between at least what this person thinks is in here and what there actually is. And some of you might say, well, just ignore the data that was beyond the warranty period, which is potentially rational suggestion. But again, once your spidey senses have started tingling and you realize that people aren't on top of being able to describe or scope a data set, it really is hard to get back to that state as a data analyst of confidence in the what's the word I'm looking for? The goodness of the data set.
Yeah, well, it's not purity. There's a technical term for it where it's not accurate. Well, somebody will think of it and let us know. There's data quality. I think the quality folks would subscribe to that one.
Well, it's representative is a word which comes to mind. Does this represent the population? But let's run with quality. Yeah. I know that we like using the word corrupt when data's bad.
Yeah.
So
honest data corrupt. Wouldn't be the opposite of corrupt data.
Yeah.
But it's part of it is it's not just, I got a stack of data, created a nice plot of it, which is something I typically do pretty quick. Is just I put it on a scatter diagram, or if it's, XY plot, or just plot it a couple different ways. Just simply get it on the screen. And there's, a handful of things you can do prior to that. And part of it is understanding, well, what are you trying to do with this? What's like you said, Chris, is what's the decision? And then I like to ask, well, what is this data? Where did it come from? And is it complete? Can it actually help us inform this decision we're trying to make? And so on. Then I often will scan a row of data and look for just blatant, like missing, does it have missing data, which changes some of the algorithms you can use to do stuff with it? Is there a row of dates, and then there's some other format for, maybe it's a date, maybe it's just a random number. Just kind of obvious stuff before you even get to plotting is like, if you have actual physical ones, are there comments that are germane to the data that you're seeing, and do you need to take those into account? or is there lots of erasures and scratching it out and rewriting it and stuff? I had one time where there was 6 different entries, all in pen, all scratched out with a line through them, and then finally one of them that was in spec, and then they shipped it. So I think they just kept measuring it until they got one that worked. That was
Right.
like, I don't think there's something quite right with the measurement system here.
Right, and that's the sort of nuances you're looking for. I mean, you talked about plotting straight away. Again, I'll go back to that example I just talked about where I had data where half of it seemed to appear after the warranty period. And you do a Weibull plot and had to make several other assumptions because I had to guess when they were manufactured as well. But the Weibull plot was pretty good in that it had infant mortality, which is what you expect to see. Then it had a nice straight wear out line within the warranty period. Still relatively small failure probability, so still, let's say, high reliability zone. But as soon as the warranty period kicked in on the Weibull plot, then the data behaved very weirdly. It started wiggling. It created a weird S shape and everything else, which is classic symptom of only receiving partial data. So, I mean, you don't just throw your hands up in the air once you have those spidey senses tingling. If you plot that, you can say, well, there's a good chance perhaps that the data which is within the warranty period is representative, but the main plausible explanation for the unusual behaviour beyond the warranty period is that those failures are not representative. And that means that the users or customers, instead of, the device is out of warranty period now, so they're going to another provider or another maintainer to fix their system. So you're only getting partial representation of those failures outside of the warranty period. So you still want to try and find the narrative, the story, like you did. Your narrative was there's a chance that we have an inaccurate measuring device, and if we keep measuring enough, the law of large numbers suggests if you have inaccuracies, you'll eventually have a number which is admittable or feasible.
Yeah.
But that's not the intent of reliability and quality in manufacturing.
I actually ran into that. I was in a factory and we were setting up a system to make measurements on a product that we were getting ready to produce, and the technician was attempting to be very helpful, and I was doing a gauge R&R where you run, various people and various operators of the system would place components in there and it would get measured and then they record it. But some of the measurements were out of spec for that particular station, for that particular dimension. And I was trying to figure out, well, is this the gauge or is this the product, kind of thing. And so I had a handful of products. I actually knew the measurements using a very different system, and they were measuring and remeasuring these things. And he kept adjusting the jig until he got a measurement that was in spec. And he said, well, they all should be good, right? I'm like, no.
Yep.
And that was an easy measurement analysis where there was a bit of human error involved.
Right.
And it was within the intention of there's a bias or perception that that's what it should be. So I'm going to keep measuring it until I get it right and get what I think it should be. Okay, that's not the idea here. Which brought into question a whole bunch of other things across that factory of how they did things and why their control charts always look so perfect. It's because instead of recording the bad stuff, they just ignored that point because it was an outlier. And this was on a control chart. Well, it can't be right. It doesn't fit in the bounds here, so it must be wrong. So we're not going to record it. Let's talk a little bit.
Are we going to talk about that thing a lot of people like calling outliers or referring to as outliers?
Well, there's that.
Love outliers.
Yeah, that's a whole other topic. But I mean, part of the initial set of data is, is it gathered well? Do I have sufficient data? Do I understand what this data is and what it represents, and what question are we trying to answer or inform, or what's the decision? All those are important. And then you get into the more nitty gritty of going, all right, I want to plot this, and hey, look at this one. This one's 2 orders of magnitude different than everything else. What's with that? Now, it could be you just created a Nobel Prize worthy discovery, or it was a missing digit or something.
It's got a Nobel Prize.
Yeah, but it's innocent until proven guilty. It is the way I look at it. And my first inkling is, depending on what we're trying to do with the data set, with this decision, I'll analyze it with it and without it. And if it doesn't change the decision, then I'm not going to invest the energy to go sort it out, because it doesn't really matter. But if that odd piece of data makes a big swing in the results that we're trying to derive from this set, then we need the story. And it's not as simple as assuming that it's an outlier and we can ignore it.
Most people don't even know what an outlier is. In fact, if you have we won't, I think we've done this a couple of times, but just, I don't know, walk down memory lane.
Yep.
When we talk about outliers, essentially you look at a data point and you say that data point is essentially valid. However, it's so far outside the typical values that's going to skew my analysis in a way I don't want it to be skewed, or in a way it shouldn't be skewed, I should say. Mm-hmm. And you say, okay, well, we'll ignore that. And it's a bit like if you're trying to understand the average height of a human being, and you're going to measure 10 humans, and then the 10th human who walks in is Shaquille O'Neal, who's 7'2", who's extraordinarily tall. And you say, okay, Shaquille, you're an outlier, so your data point won't count. But the problem with that is an outlier, by definition, requires prejudice, prejudging.
Yep.
It means you need to already come into that conversation with an idea about what you expect or what you think is satisfactory, or tolerances, or insert whatever word you like using there. And if it's not what you expect, you call it an outlier and exclude it, which is classic bias. That is the definition of bias. You exclude data because it doesn't fit your preconceived idea of what it should be. And when it comes to manufacturing, that's a huge deal, because you might have, like, for example, intermittent faults that, they're just things are out of spec at startup and shut down. And if you say, well, those things are okay, they're an outlier, so they hardly ever occur. They only occur at the start and the finish. So we're going to exclude them. Well, if you're trying to manufacture things with 6 sigmas worth of quality, whatever you want to call it, or you just cannot tolerate huge, even small numbers of defects, well, you've just potentially created a huge problem later on with recalls and quality control issues once the users and customers have it, et cetera, et cetera. You should almost never look at something and then say, and feel confident enough to say that's an outlier, so I'm going to pretend it doesn't exist. Yep.
Yeah. No, you got to know the story of the data. If it's an honest clerical error, or if you can demonstrate or show that it was just a transposed figures, or it was somebody wrote 2 results down in the same cell, so it ended up with 3 extra digits. Those kinds of things, but you need a pretty clear evidence to exclude it, which is exactly what you're saying. I think is that no, it's information, and we shouldn't exclude it.
Well, that's not really an outlier. That's like incorrect data. I mean, the outlier is where you measure Shaquille O'Neal perfectly, and you turn, oh yeah, you are still 7'2".
Yeah.
So that data point is not corrupt per se. No one.
There's nothing wrong with that. No.
Right. Yeah. What you're talking about is where someone writes down 7'2" wrong. So instead of it being 7'2", he's 72 feet tall.
Right.
That's not an outlier. That's a corrupt data point.
Yeah.
But
and it's not always easy to tell what's corrupt versus real when it's a bunch of automated measurement systems and data sets being moved from here to there, and people fussing with it one way or the other, and it gets tracking down what's the difference between corrupt data and an outlier is much it's much easier if you just assume it away and just I'll ignore that.
And that's why people do it.
Yeah. but it's to your own peril for lots of different reasons. So what did we come up with so far? Like 5 or 6 different things we do with data pretty quick and understand it. And then we have fun with it. We plot it this way and that way, and then we run this analysis, that analysis. We do regression. We do, whatever it is that we're trying to do with the data set. Then it's fun. There's a bit of work before you get to the fun part.
What I like doing with data analysis is I form an idea in my head of what I expect to see based on the description of what this process models. Mm-hmm. So again, we'll go back to that example. It's a mechanical system, so I expect to see infant mortality. I expect to see transition to wear out based on my understanding of that product. I am open to the idea of seeing a small period of constant hazard rate between those two regions. So I'm expecting to see these things, and that's not prejudice per se, because you're still basing your critical thinking on the scenario at hand. But why I like doing that is because it sort of allows me to formulate what my expectations are from a data analysis perspective based on deducing how this thing works.
Yep.
And if the said Weibull plot or whatever it is aligns to that expectation, that's a good sign. And it gives you more confidence that the data is representative and not corrupt, honest, as you say.
Yeah. Well, I had, it was a physics class professor, and his weekly quizzes that we got was often just make a guess. And it was trying to hone our ability to take the relevant information, which often was very sketchy and very slight, and often sometimes would even be just really weird questions, like how many piano tuners are in Manhattan?
Okay.
And we knew roughly how many people, order of magnitude maybe, how many people were there, and then you'd work out and show your work. What did you make assumptions, and how did you come up with your number of piano tuners? And there wasn't a right or wrong answer oftentimes, but he said if you face a problem and you don't have an idea what the answer or the result or what you expect the answer to be, then you don't, when the calculator or the computer finishes the run, or you finish the running out the calculations by paper by hand, you need something to compare it to, and
Yep.
so sometimes all you have is your intuition or a guess. And so that's another good one. Is what do you expect to see with this data set? And sometimes you're surprised, and it's a valid surprise. And sometimes it's like, okay, that makes sense. That's consistent. But it's hard to be surprised when you don't know what you're expecting.
Right. And it goes to the point where we sort of preach that when we use software or data analysis tools, you can't just be monkey see, monkey do, rubbish in, rubbish out. If you just get numbers and say, well, here's the answer, but you don't understand what those numbers mean, where they come from, you haven't checked, they align with what you think or what you'd expect you would see, then you are not an engineer. You are a poorly put together cyborg that's not going to be useful for too much longer.
Yeah. No, that brings up a whole other story where we had negative time to failures, and that's kind of an odd result. How does that happen? But, so anyway, what apparently, and when I first saw it, it was like, what do I first do when I get a set of data? Well, I plot it. And he says, well, what do you really do? And I thought, well, that'd be a good question for Chris. So hopefully that wasn't too much of a surprise or shock for you there, Chris.
Oh, it wasn't a shock.
You never know. I got another one for you. I'll save that for later. But anyway, if you're listening to this, if you got a question, even straightforward, simple questions, we like those. Those are easier to answer. But sometimes there's a little bit of thought goes into some of this stuff. And if you've got something on your mind, let us know. Head over to accendoreliability.com/go/SOR. And Chris and I and the other hosts of the show are available through LinkedIn or through our About pages, where there's a couple different ways to get in touch with each of us. And we'd certainly like to hear from you and what's on your mind. So with that, Chris, I'm going to go see what if there's a data set that this person had, see if I can go play with that. But I didn't actually see the data, so I'll have to ask.
Fair enough.
All right, cool. Well, thanks, Chris. Talk to you again soon.
Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.